Okay, question number 19. An amplitude of wave, a plane wave of amplitude A is incident on the surface of area S placed so that it is perpendicular to the direction of the travel of the wave. Okay, so somewhere amplitude is given, surface area is given. Whenever amplitude is given, you can find intensity, which is I is proportional to A square. On the surface of area S, it's perpendicular. Okay, the energy per unit time is what? Power reaching the surface E. So instead of giving the letter P here, is given E here. Okay. Now the amplitude of the wave is increased by 2A, and the area of the surface is reduced to half S. Okay. So first what we do is you have one source, and then you have an area here, which is S over here, and then let me write this as source here because it will not confuse over here, right? So the intensity reaching this surface is equal to energy per unit area per unit time, which should now be equal to something like A square divided by D square. A square by D square. What is D? He has not given the D, but I assumed D here. D is a distance from the source to the object over here. Now, when he says the amplitude of the wave is increased to 2A, when this amplitude was A, this is the answer. But if this amplitude becomes 2A, distance remains the same, then what happens? Your I dash becomes 4A square divided by D square. Okay. Next, we also know that intensity is given by energy per unit time per unit area. Energy per unit time is power. Power by area is intensity. Remember this. Okay. Energy per unit time divided by area. So towards it now, if I want to find energy per unit time, which is what you call as E here, or power. Okay. Which means energy per unit time is equal to I into A. What is A here? I into S over here. Okay. I into S. So therefore, I will now write this just as E. Why E? Because he says E here, it is E over here. Okay. So therefore, E is equal to I into S. So for the first surface, I can now write E is equal to I into S. In the second surface, this was seen to be reduced to S by 2. So E dash is equal to I dash into S by 2. Hey, we have written everything, but what is that he is asking? He is asking you what is this E dash in terms of E. That's what is been asked. Now what we will do is, we will just divide one by the other. E dash by E is equal to I dash S by 2 divided by I into S over here. This goes away. So I get this as I dash divided by 2I. That's what I get. Remember, I is not current. It's intensity here. Okay. Now for I dash will substitute. What is the I dash here? 4A square by D square. And for I will substitute. I'll write this as 2 times I. What is the I here? A square by D square. This goes away. 2 1s are, 2 2s are comes over here. So this should be 2, or E dash should be equal to 2 times E. That's the answer. Okay, such kinds of problems are called as comparison problems. If you wish to know more about it, you can go to my website, which is ibphysicswithrao.com, or you can also go to my homepage, which is ratankar.com, and there you will be finding out something like a link to misconceptions in physics. Okay, go to that link, and there you will find out something like the comparison problems. So go to comparison problems. There you will be able to find such kinds of problems. Okay, thank you. Please subscribe to my channel before you leave this video. Thank you.